Hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is rank transform of an array. So before we get started, I just want you guys to know that we have a full PDF solution provided in the description below. Just go in the description, find the GitHub link, and you can just download this PDF so that you don't have to revisit this video again and again, even in the future. So it has the intuition, approach, time and space complexity with the code itself. So let's get on with solving the problem. So what is this question asking? Given an array of integers r, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. Okay. So we have to assign a rank to every integer and it should satisfy these three rules. So rank is an integer starting from 1. Okay. The larger the element, the larger the rank. If two elements are equal, the rank must be the same. And the rank should be as small as possible. So where do you use these kind of this approach? It's more or less when you are organizing an exam. But the thing is, the larger the element, the smaller would be the rank. So this is something that is used in real life, just so you know. Now let's look at the test cases. We have 40, 10, 20 and 30 with rank 4, 1, 2, 3, and the reason being 10 is the smallest, so rank is 1, the smallest one. 20 is the second smallest element, so rank is 2. 30 is the third smallest element, so rank is 3. 40 is the fourth smallest element, so the rank is 4. Now let's look at this one. So input array is 100, 100, 100, so that means every element should have the same rank, which is 1 itself. And if you look at this test case, the only number that is repeating is 12, and 12 is the third smallest number, so 3 and 3 is repeated. Fine. So how do you approach this? Now when I look at this test case, I know there is something that is related to unique elements, right? So if two elements are the same, their rank must be the same. So I need to determine the uniqueness of a number, or in other words, I need to use a set data structure because set stores unique elements. At the same time, the order really matters. The way that you are using the elements in the set actually matters. So like 44 is in this position, 10 is in the first index, index 1, so 1 is in position 1, 20 is at index 2, so 2, 30 is at index 3, so 3 is placed here. So the location also matters as well as the uniqueness. So that is the approach, the idea, the way that we are going to do this. Now let's look at the solution. So since we require something related to uniqueness, I use a set data structure, and what I do is I place all the elements in this array in this set. So now what is the time complexity? So for every element, for placing the set would take log n time, and since we have n elements, so the time complexity for this statement alone would be n log n. Fine. Now we need to determine the rank of every element. So let's say I initialize the rank as 0, and this map would store what? This map would store the array element and its corresponding rank, so the number with its rank. So that is what I'm going to do. I would traverse the set and I would say that MPP of element, so that means this element should have rank this. Now what this does is plus plus rank is basically you take this value, you increment 1 to it, and that is what you assign to this element. So very first time when you go into this for loop, rank is 0, but you do plus plus, so rank is now 1, and that is what you assign to this element. The smallest element is assigned the rank 1. Why are we able to do this? Because since we are using a set and not an unordered set, so while you're traversing the set, you would have the elements occurring in an increasing order. So that is the property of the set that we are using, so that this traversal is as simple as possible and quite straightforward. Now what I do is for every element in this array, since I have the rank for every element, what I do is I say array of I is equal to the rank of that array of I. Okay, so MPP is basically storing the rank of every element, right? So MPP would get the rank of this array of I, and that is what it would reassign in this original array itself. And since you say replace each element with its rank, that is why I'm reassigning the value to itself. No, I'm not creating a different array, and it's not that array that I'm returning. It's the original array that is provided as an input that I'm returning and updating the elements in. So MPP is still storing the rank, and that is what we are assigning. Okay, so problem is done. It's accepted. Now let's discuss the time and space complexity. the time complexity for this is itself is n log n, and space is big O of n because you're storing n elements, right? At max in the worst case. Okay, so now again in this unordered map, what you would do is store all the n elements. So this would also take big O of n space. Now assuming I'm using this unordered map and it works at an amortized time complexity of constant time, what I'm assuming is this statement is constant time operation, and for traversing the set we would take big O of n time here as well as big O of n time here in the worst case. So the time complexity is dominated by big O of n log n, so the overall time complexity is n log n. Finally, the space complexity is big O of n for this, big O of n for this, so big O of 2n, which is big O of n itself. So time is n log n, space is log n, or space is linear time. So that is the solution, and yep, it's this is what I wanted to explain this to you. Be sure to check the link in the description to get the PDF solution for this problem. Yep, thanks for watching, and I'll see you in the next one.